At a very young age, children learn the concepts of big and small. Over time, this develops into the ability to compare quantities. This remains completely intuitive for most people right up until negative numbers are introduced, and this is where problems start to arise. We think of negative 100 being big and 10 being small, yet we have situations, such as with temperatures, where 10 is above negative 100. However, we can avoid these problems by avoiding bigger and smaller and using greater than and less than as comparison phrases. These words refer specifically to the ordering that we give numbers on the number line. In order to ground ourselves in the language and the notation, we will start by using an example with positive numbers. Example, locate the numbers 2 and 5 on the number line. Although this is very easy, we will be doing this to reinforce a pattern of thought. We will draw out the number line first. Here are the locations of 2 and 5. We know that 2 is less than 5. We will write this in the following notation. This symbol right here is known as the less than sign. Geometrically, it means to the left of. 2 is to the left of 5. If we wanted to say the same thing but in the opposite way, we would say 5 is greater than 2. The symbol is known as greater than and means to the right of. Incidentally, for those who have a musical background, these symbols match crescendo and diminuendo in shape and meaning. You can think of the numbers as representing volumes, so that 2 is less than 5 means 2 is getting louder to 5, and 5 is greater than 2 means 5 is getting quieter to 2. Once we understand these values geometrically, working with negative numbers becomes very simple. Example, plot the numbers negative 1 and 4 on a number line, and write two different mathematical sentences comparing them. We will start off by drawing the number line. And then we will locate the numbers negative 1 and 4. Which number is to the left of which? Negative 1 is to the left of 4. Negative 1 is to the left of 4. And which number is to the right of which? 4 is to the right of negative 1. 4 is to the right of negative 1. If we read these off in the standard mathematical language, this reads negative 1 is less than 4, and 4 is greater than negative 1. Example, write two different mathematical sentences comparing the numbers negative 5 and negative 12 without drawing a number line. How do we visualize this picture? Let's say that you're at the number negative 5 on the number line. Which direction do you need to move in order to get to negative 12? You should have enough intuition by this point to know that you have to go to the left to get to negative 12. And now let's think about the geometric relationship between these two values. Negative 12 is to the left of negative 5. Negative 12 is to the left of negative 5. And negative 5 is to the right of negative 12. So negative 12 is less than negative 5, and negative 5 is greater than negative 12. By sticking with the number line visualization, this section should not be that difficult. The problems arise when students start trying to memorize rules about how to compare numbers. When they're both negative, then you flip them and things like that. It's much easier to just look at the picture and think about it.